Imagine a world millions of years in the future. A world where evolution has written a new chapter in the story of life. The world is inhabited by very strange creatures, like nothing the Earth has ever seen. "100 million years in the future, a huge rainforest. Dark, dense, and crowded with life. Strange birds and weird insects compete for food and space. But this forest is really bizarre. Not because of what lives here, but because of where it is. These lush forests cover the land that was once the frozen continent of Antarctica. Today, Antarctica, lying over the South Pole, is buried under thousands of meters of ice. So cold and bleak, it's almost empty of life.
Well, Antarctica, which is presently located over the South Pole and glaciated, has in essence been sterilized of most living things by the presence of the ice that has just literally rubbed them off and offers no place for an animal or a plant to grow.
But Antarctica hasn't always been an icy wilderness. Long ago, it was covered in forest. And it could be again. Because Antarctica is on the move.
As we approach 100 million years in the future, it begins to move off the South Pole, move northwards into warmer environments. But during this process, as it is in the present day, it has remained an isolated continent. So the only way that organisms are going to get to it is by long-distance dispersal. And this means that only certain kinds of organisms, things like birds or plants that have very small light seeds, only certain organisms are going to make it. And the end result is that the kinds of communities of plants and animals that develop on Antarctica are going to be highly unusual.
Although the communities here have evolved from very few original colonists, they now look like the animals and plants in rainforests today. That's because they live and eat in the same way.
100 million years in the future, Antarctica will be much further north than it is now. It'll be very different. It's not going to be covered in ice. It'll have trees and vegetation and all the animals which go with a habitat like that. The birds, though, which you'll find in Antarctica in the future, will have evolved while Antarctica was further south. They've therefore got to evolve from the species which are there now.
So birds were here all the time, though now they look completely different from their ancestors. What gives away their origins is their strange nostrils.
Our flutter birds are immediately recognizable as coming from a group of birds we're familiar with today. They have tube noses. The tube-nosed birds are called the petrels, and they're one of the dominant species in modern Antarctica. The best example of the albatrosses. They're tube noses because they have two small tubes on the top of the nose. We think this is used to measure the air currents, but we don't know that yet.
Ocean-going petrels turning into tiny, colourful forest birds. Even that's possible, because they could adapt over millions of years as Antarctica slowly changed. The continent is moving, and as it drifts north, away from the South Pole, the ice begins to melt. Further north, and the bare surface of the land is exposed for the first time in millions of years. As soil developed, grasses and sedges turned Antarctica green. Eventually, millions of years later, Antarctica arrived in the temperate zone, where trees could grow into the first forests. And once Antarctica reached the tropics, the cool temperate forests were replaced by dense rainforest. All this time, the Antarctic petrels had the continent to themselves, changing, evolving, turning into hundreds of new species. Flutterbirds, each kind finding its own way to make a living. But even a tiny change in design means a bird can make a living in a completely different way.
When you look at modern birds, there are perhaps 9,000 or 10,000 species of birds in the world today. They're very similar in the basic way they're built, but the different species all vary from each other slightly. They vary in the shapes and sizes of the wings. They vary in the beak and the feet, all kinds of features. Where they vary in the wings, this is because they're flying in different ways. You can look at a group of birds, say in a northern forest, half a dozen species of tits and similar birds. Some are flying around the tips of the branches, some are feeding on the bark, the trunk of the tree. And if you look at those birds, they'll all differ slightly in the design of the wings or the feet or the beak. Same principle that their design relates to the way they're feeding and what they're eating.
Optimum wing design is vital, particularly to a pursuit hunter like a sparrowhawk. It has short, rounded wings for fast, maneuverable flight, dodging and twisting through the forest as it chases smaller birds. In 100 million years' time, different wing designs mean dozens of different types of flutterbirds can make a living in the Antarctic rainforest. Some soar over the forest on long wings, others fly through the canopy on broad wings. But the most agile and maneuverable is the roach cutter. So fast, it can even snatch insects off a branch in flight. But some insects in this forest are simply too big to eat. This is a falconfly, and it eats birds. In this forest, the meanest predators are insects.
Today, the size of insects is determined by the richness of oxygen in the atmosphere. Oxygen is absorbed via little tubes inside the animal, and an insect can only grow so large. If the atmosphere were enriched in oxygen, they could grow bigger. It's happening in the future, but it happened in the past. In the Carboniferous coal swamps, there were huge dragonflies. There were millipede-like animals on the forest floor which were truly terrifying. They could get much larger because of the richer atmosphere. Well, it can happen again in the future, perhaps sufficient to turn an insect into a major predator.
The falconfly is a giant wasp. It has front legs that can spear birds in flight and powerful jaws to butcher its prey, as well as a venomous sting. The falconfly doesn't just eat the roach cutter, it carries juicy bits of its victim back to a hole on the forest floor. The hole is really the falconfly's nest. And living deep inside, its young is a massive 15-centimeter long maggot. A mother falconfly has to find a lot of meat to feed its monstrous baby. Surely such tender maternal care is unusual for an insect.
There are two strategies for reproduction if you're an insect. One is to lay vast numbers of eggs, of which only a few survive. The other is to lay very few eggs, but take special measures to ensure a high rate of survival. That's what the falconfly does. And there are many analogues in the living fauna. There is, for example, the sexton beetle that lays very few eggs on, for example, a buried mouse and nurtures its young, actually feeds them to ensure a very high rate of survival.
So even today, insects aren't always absent parents. The falconfly has another problem. Not only does it have to find enough meat, it has to remember where the nest is.
Some insects have evolved very sophisticated ways of locating their larvae. They use the polarized light produced by the sun for navigation purposes. They have a memory for landmarks, and this enables them to very precisely retrace their steps.
The falconfly's ancestor, the sand wasp, also hides its maggots in holes in the ground and feeds them on paralyzed caterpillars. To find its nest again, it memorizes landmarks around the hole, stones, twigs, or plants. It's so confident it can find its burrow again, it even covers it with sand, disguising it from predators. The falconfly has a bigger problem. It has lots of nests scattered all over the forest and has to remember where each one is. A challenge for any insect. But there is one today with the brain power for this. The honeybee. A honeybee can remember the location of up to 4 different flowers. And even more, it remembers the time of day when each flower produces nectar. And they can find their way home from 4 kilometers away. To help returning bees, bees at the hive waft a scent from their tails. a kind of instrument landing system for bees on final approach. The falconfly has inherited all its ancestors' skills and easily finds its way back to each of its holes through the tangle of rainforest. But not all the birds are helpless against the giant falconfly. The Spitfire bird is another kind of flutterbird, but one with a deadly weapon.
The Spitfire bird has developed an extraordinary way of defending itself against predators. It squirts a hot, noxious fluid from its nose.
The explosion is caused by mixing two chemicals, each stored in a separate chamber. When threatened, the bird squeezes both chemicals into a special reaction chamber in its tubular nostrils. The two chemicals react violently, forcing the noxious steaming spray out of the nose.
Well, by mingling these two chemicals, the Spitfire bird makes a poisonous and hot spray. It may sound improbable, but among living animals there is the bombardier beetle, which does a similar mixture of two chemicals and produces a really hot spray which repels any predator instantly.
The bombardier beetle is patterned in black and yellow, a warning signal. Bright colours, black with orange or yellow, is insect code for leave me alone. The dazzling monarch butterfly is full of poisonous chemicals that leave a disgusting taste. And these red and black bugs hang around in gangs to reinforce the signal. And both the bugs and the monarchs get their nasty chemicals from the plants they eat. But in the future, the Spitfire bird's defense comes from a much closer relationship with a plant. This rainforest tree. Instead of sipping nectar, it sips chemicals from the flower. Highly reactive chemicals. So both chemicals can't be in the same flower or they'd explode. So the tree has developed male and female flowers, each with one of the chemicals. This forces the bird to visit both flowers in turn, providing the plant with a first-class pollination service. Falconflies are smart enough to stay away from the bright yellow colours of the Spitfire bird. But this time, it wasn't a real Spitfire bird.
The false Spitfire bird looks almost exactly the same as the real Spitfire bird. It's what we call a mimic. Nature is full of mimicry. Very often this mimicry is when a non-poisonous animal or a non-dangerous animal resembles a dangerous one. Very often the coloration is bright, a warning coloration. Think of bees and wasps. Think of brightly coloured banded snakes. A predator is confused by this resemblance. So the non-poisonous one benefits from its resemblance to the poisonous one, and both are left well alone.
This is a deadly coral snake, and its bite is fatal. Predators learn to stay well away from its bright colours. But this is a harmless milk snake, and it looks just the same. In the heat of the moment, even the smartest predator can't tell them apart, so takes the safe way out and leaves the harmless snake alone. In the Antarctic rainforest, there are some very clever mimics, and they use their color schemes for a much more sinister purpose. These future beetles have evolved a way of tricking Spitfire birds and avoiding the spray of hot acid. They work together to mimic a flower of the Spitfire tree. They have wings and wing cases that are colored and shaped just like the petals of the Spitfire flower. And 4 of them, head to head on the trunk with their wings at just the right angle, transform into a flower.
Nature is full of camouflage. There are insects which imitate plants, leaves, flowers. The flower mantis, for example, carefully arranges its appendages, its limbs, so that it looks like an orchid.
Its disguise is good enough to fool most other insects. And mimicking a flower has another advantage. Your prey comes looking for you. But a mantis works alone. These beetles have to work together to catch a Spitfire bird. Insects cooperating like this seems like a science fiction nightmare of the future. But today, even outside the social world of ants, bees and wasps, there are insects that work as organized units. These sawfly larvae live and move as one, sending out signals, a sort of communal Morse code tapped out on the branch, to any of the group that gets lost. They huddle together like this for defense. And if attacked, they present a united front, a barrage of foul-tasting gobs of vomit. But a flower made from cooperative beetles is more elegant, both in looks and in being the perfect way to catch Spitfire birds. They only visit flowers when they run out of chemicals, and that's a good time to pounce. For the falconfly, these Antarctic rainforests are crowded with life. Evolution is an arms race. Attack and defense, measure and countermeasure. And to win this war, creatures in this forest must come up with new tricks and new alliances. It's places like these rainforest battlefields, where animals and plants struggle to stay one step ahead of the game, that the powers of evolution are tested to the absolute limit.